Okay, nerds, Unit 2.1b, the back half of change in arithmetic and geometric sequences. We've already started this stuff. We did it on Friday, the day after Halloween, so many of you were absent. It was quite the quiet day. On Friday, we covered arithmetic sequences. And to remind you what that means, a sequence is a list of numbers. They need to follow a pattern. An arithmetic pattern means you are adding or subtracting the exact same number every single time. Call that the common difference. The common difference is found by doing any number minus the one before it. And this is the general term for an arithmetic sequence. If you start at the first term, you take the common difference and multiply by n minus 1. That could be re-indexed to get you any term you want without knowing the first term. And we could also even discuss the fact that it's actually a linear model, but you have to talk about a sub 0, which would mean the 0th term, which is kind of strange, but that means, well, what would have happened before the first term? We could do all that stuff, but for geometric as well. But what does it mean to be geometric? Well, arithmetic meant adding or subtracting the exact same thing every single time. Geometric means multiplying by the same thing every single time. So a geometric sequence is any sequence with a constant ratio. We don't call it the common difference. We call it the common ratio. Between two consecutive terms, you could have any starting value you want, a or a sub 1 or whatever, and r is the common ratio. I like to start things with a sub 1, so this would be a1 times the ratio, a1 times the ratio squared, so on and so forth. But for now, we're just going to leave them as a's. Here's an example: 4, 8, 16, 32, yada, yada, yada. We are doubling each time. That means multiplying by 2 each time. This would be a general form for that. 4 times, well, how many times did you want to multiply by 2? Multiply by 2 once, twice, 3 times, 4 times, whatever, okay? But if we're talking sequences, we probably want to use the general term, the nth term. A sub n equals a sub 1 times r to the n minus 1. Just like with arithmetic sequences, the reason why you have an n minus 1 here is because there is no such thing as the 0th term. A sub 1 should be the number you have before you have multiplied by r, before you have multiplied by r at all. So if you use n equals 1 here, you get r to the 0, which equals 1, and that disappears, and you get a sub 1 equals a sub 1. So that's why it has an n minus 1, because we don't start at a sub 0, we start at a sub 1. And just like arithmetic sequences, these can be re-indexed. You don't have to start with the first term if you don't want to. You can start with any term you want, and we'll talk about that in a second. You can start with any term you want as long as you know how far away your ending term is. If you're trying to go from the third term to the 7th term, well, you only have to multiply by r 4 times. Just like if you were trying to go from the 3rd to the 7th term with arithmetic, you added d 4 times. So it's just a fast way of getting between terms. Reindexing is a good thing. For arithmetic, I already showed you, but the common difference is found by taking any term and subtracting the one before it. Since geometric things are defined by multiplication, the common ratio can always be found by taking any term and dividing by the one before it. So here we have the general term, and here's another way of writing it. Now, I don't know why they switched over to G. I mean, these could say A of N, so don't bug out about it. In fact, I'm just going to rewrite it because I don't like G. I like A. I believe the author of these notes used A for arithmetic and G for geometric, but I've only ever seen these things defined as A sub N or U sub N. I've never seen them with other letters other than that. So I'm going to write it as A sub N. That doesn't mean it's arithmetic. That just means some sequence of terms, okay? This is the formula if you reindex it to begin at a sub 0. So for this one, if you want to know a sub 1, you have to actually plug in 1. It's what you get if you took the thing before the first term and you multiplied it by the common ratio. I know that's a weird sentence to say. But it's essentially it's this one if you just reindex to make that a 0 instead of a 1. And if you can reindex it to 0, you can actually reindex it to anything you want. For example, so I'll just write an example of reindexing this formula to be anything we want. Let's say we want the 33rd term. And we have the 25th term. How far apart are those two terms? 33 and 25. 8. So if you multiply A25 by r to the 8th, it'll get you to A33. So that's the way of reindexing the formula. Notice I didn't even use the first term. So I could, but I don't have to. And something that didn't come up in the last set of notes on Friday is the arithmetic mean. I'm assuming the reason why it didn't make it into the notes is because every one of you should know how to find the mean. Right? Okay. So the arithmetic mean between two numbers is add those two numbers up and divide by 2. The reason why that works, well, the reason why we call it arithmetic mean is not just average or mean is, let's say I gave you a sequence, I tell you it's arithmetic, right? And I say, this one's a 2, you don't know that one, but you know this one's a 7, yada, yada, yada. And I tell you it's arithmetic. If I ask you to find the middle number, then you would just say, oh, 2 plus 7 divided by 2 is 4.5. But that assumes that there's a common difference. You see, to go from here to here is plus 2.5, and then go from here to here is plus 2.5. It's called the arithmetic mean because it follows an arithmetic sequence. There is such thing as a geometric mean. And it says, if you would like to know the value that is between two values in a geometric sequence, it's the square root of their product. So let me write up something real quick. 2 blank and then 18. And I say this is geometric and I want you to find the missing number. Can we agree that to go from 2 to 18, I had to multiply by r twice? What am I talking about? To go from 2 to 18, I had to multiply by r twice. I'll be okay. Right? You divide both sides by 2. And now you can tell me that r is positive or negative 3, right? So this number must be 6. The faster way of doing that is finding the square root of their product. Do you need to memorize this? No. You saw that I just did it without that formula. But there is a formula for it. And if you're interested, this does have real-world use. It's used in finances. It's really good for playing with other people's money. If you study money, you make money. Remember that. And if you ever become, I don't know, anything that uses finances, like a financial advisor or anything like that, I need you to do several things for me. Number 1, I need you to thank me. Number 2, I need you to give me a job, okay? Because, hey, you know, teaching barely pays the bills. And number 3, I need you to slap the next person that says, what am I ever going to use this in real life, okay? Yep, what's up? This is geometric because it's multiplication. No, this is here it is for arithmetic. This is just reindexing. This is a way of, see here, the 14th term is 4 differences past the 10th term. But if it was geometric, you'd have to say the 14th term is a10 times r to the 4th power. Because it's times r times r times r times r. All right, so we're looking at these sequences and we want to know, are they geometric? And if so, what is the common ratio? Well, that just means, is there something you're multiplying by every single time? Does that pattern hold true the entire time? Is there something I'm multiplying by to get from 3 to 6, but it's also from 6 to 12, it's also from 12 to 24? Yeah, what am I multiplying by? Yeah, buddy, multiplying by 2. R equals 2, so it is geometric. Can you see multiplying by something over and over and over again here without fail? Yes. What is it? -3. Ah, the common ratio is allowed to be negative. The common ratio is allowed to be negative. Is this sequence using multiplication? Nope. That means it is not geometric. This one is actually arithmetic because, well, it's going up by 4 each time. So this one's actually arithmetic, not geometric. Oh, something's not geometric, it's automatically arithmetic? No. In order to be arithmetic, you have to show that you are adding or subtracting the exact same number every single time. This one happens to be arithmetic with a common difference of 4. And this one. Am I multiplying by something over and over and over again to get from 48 to -12 and then from -12 to 3? -1/4. Yes. So this is geometric. We are multiplying by -1/4. Notice I said that to get from one term to the next, you are multiplying by something. Some of you might have been thinking, oh, I'm just dividing by -4. No. There's no such thing as division. There is only multiplication by whole numbers and by reciprocal numbers. This happens to be a reciprocal number. Cool? Everybody can see why these three are geometric, but this one is not? Yes. Awesome. You also could check for geometric by doing 9 divided by 5 and see if it's equal to 5 divided by 1. It's clearly not equal. 9 divided by 5 is 1.8, whereas 5 divided by 1 is 5. So clearly there's not a common ratio. Yes? Can a sequence be both? No. Because to go from one term to the next, you have to add the same thing over and over and over again to be arithmetic. And to go from one term to the next using multiplication by the same thing over and over and over, that would classify it as geometric. Now, can I write a sequence that uses both ideas? Sure. But you wouldn't classify it as both. You would just say, oh, look, there's a sequence and here's its formula. Yeah. And I wouldn't ask you to find one of those by hand without walking you through it a little bit. We do that in IB. In fact, my students had a test question like that today on their IB test, where they had a list of stuff, and the first half, well, it's harder to, it'll be easier just to show you than it is to say it. I'll just show you this question right quick. IB what? IB math analysis for short. IB analysis and approaches. Right here. It goes from 1 plus k to 5 plus 3k to 12 plus 7k to 22 plus 15k. As it turns out, the numbers on the front follow an arithmetic progression, where the k's follow a geometric progression or something like that. I might have it backwards because I'm just saying it real fast, but it's actually a blend of the two. It's really neat. Yes? Curvy E and double struck Z. This means element of, and this means the integers. Some of you will be IB students in the future. You'll learn then. But you're not going to learn today. Okay? Next. All right. You are told that this is a geometric sequence. That means there's a common ratio. Well, should be pretty easy to find since there's a list of terms here. The common ratio is any term divided by the one before it. So I have a common ratio of 5, -5, excuse me. And I can see my first term is 3. So I'm going to find a sub n, and then I'll use that formula to find a sub 6. Here is your general term. Gentlemen, this thing will be able to hear that you guys are talking constantly while I'm recording. You won't be able to hear what you're saying, but it'll be obvious that there's noises in my room. So a sub n is a sub 1 times r to the n minus 1. And if I want a sub 6, I can plug it in. Plug in 6 for n. And hopefully everybody in the room remembers that they learned this stuff in Algebra 2 Honors. None of this is new. Yes, you did. What? Where did n come from? Do you mean the general term n? It's just part of the formula. It's an unknown. And we said we want to find 6, so n is 6. Now this number's big. I don't know it offhand. That's not true. I do remember from last period. But if I didn't, go 3 times negative 5 raised to the 5th is negative 9375. It's pretty straightforward when you know the list of terms is geometric and you can see the first one and the second one. It's pretty straightforward. But what if you can't see the first one and the second one? And instead I tell you the fourth one and the 11th one. We need to use common sense and the reindexing idea. How many times would I have to multiply by r to get from the 4th term to the 11th term? 7 times. I would have to multiply by r 7 times to get from the 4th term to the 11th term. A sub 11 is a sub 4 times r to the 7th. Why? Because those are 4 places apart. Excuse me, 7 places apart. Sorry, I was looking at the 4 when I said that. There's 7 places apart. So fill out what you know. 1 over 16 equals negative 8 r to the 7th. Going to multiply everything by negative 1/8. Instead of saying divide by negative 8, because it's already a fraction. So instead, let's multiply by negative 1/8. 8 times 16 is 80 plus 48 is 128. So and it's negative. I have negative 1 over 128 equals r to the 7th. And how do we cancel 7th powers? 7th root. Okay, 7th root is kind of a pain in the butt to track down and learn how to use the nth root feature of the calculator. So instead of saying 7th root, which isn't wrong, instead of saying 7th root, let's use an exponent. 1/7 power. There it is. Also, Algebra 2 skills. So r equals negative, because it's okay that we're taking, that there's a negative argument. That's all right, because it's an odd root. That is just fine. So I'm going to say negative 1 divided by 128. See, I closed up my parentheses, and I'm going to raise that to the 1/7, and I'm going to hit equals, and it's going to tell me negative 1/2. Yep. What's up, Cooper? Okay. So r is negative 1/2. Oh, okay. Yes, Cooper?
Did we ever get something like that where we had to do it to, like, it wasn't odd?
You want to know if you could have an imaginary common ratio?
Yeah.
No, you won't do that. Not in this class. Could you? You could. But we're not going to. It didn't ask us to solve for r. It said determine r and a sub 1. Then let's use our reindexing idea. How far away from a1? How many terms from a1 is a4?
-3.
How many terms away is it?
3.
3 terms away. So let's use that idea. a4 is a1 r cubed. We know a4 is negative 8. We don't know a1. We're working on it. But we do know that we have negative 1/2 to the 3rd. That's negative 1/8. Because negative 1 cubed is negative 1 and 2 cubed is 8. So simply multiply both sides by -8 and you will have A alone. Please use parentheses if you're going to write it over there. What you get is A sub, forgot my 1. You get A sub 1 equals positive 64. Ta-da! Questions, comments, concerns? From a question like that where you get to use the whole reindexing idea, talking about the number of terms between two things. None. Okay. Then let's move on. Boop, boop. When a radioactive substance decays, the amount remaining will form a geometric sequence when measured over constant intervals of time. The table shows the amount of unknown substance initially and after 2 hours. There we go. Find the amounts left after 1 hour, 3 hours, 4 hours. Round your estimates to the nearest gram. Gavin, is that about to be a question? Okay. You mean A sub 0. So A sub 0 is a starting amount. That is not how much is left after 1 hour, which would be A sub 1. So A sub 1 is not a starting amount. A sub 1 is the first term of the sequence. It's how much you have after some event has occurred. Okay? So if you want to write a formula with A0, you can. You just have to make sure that it's R to the n and not R to the n minus 1. Okay? It is a y-intercept. It's exactly what it is. It's a y-intercept, but when we start counting, nobody starts counting at number 0, do they? Right. So that's why we don't start our sequences at A sub 0 either. Alrighty. What do we see? How many times would I have to multiply by R to get from here to here? 2. So what I know is that 384 is the result of taking 1320 and multiplying it by R squared. Because it's 2 terms away. So you divide both sides by R squared. No, stop that. That doesn't make any sense. You divide both sides by 1320. I hope it's pretty. Poop. It's not. It's not pretty at all. That's what R squared equals. And so to get R alone, I take the square root of that. You guys know about second answer? So copy and paste the last answer you just did. It's right there. And hit enter. Ooh! Okay, R is even worse. To 3 decimals, R is 0.539. Let's track down A1. Yeah, well, that's supposed to be an equal sign. You know, my calculator already has that number in it for me. I didn't clear it. So all I have to do is hit times 1320 and hit equals. Boop, there's the answer for that one. Yes, Cooper?
We rounded though, and then just multiply by 0.539.
Slightly different, but it did say to round to the nearest whole number for your answers here. So this is going to be 712. Let's see if we had just used 0.539. 1320 times 0.539. Would have been a little bit off. Right, but because we can use this calculator on the AP exam, we want to know how to do it this way. Okay? Let's track down A3. Can we agree that A3 is a single R away from 384? See that? Just times R one time. Yeah. So I'm going to take this 384 I'm going to multiply it to the 0.539. I forgot to write 712 in blue. And again, I don't want to round. I want to try to be as exact as possible. So here's what I'm going to do. 384 times, and then I'm going to scroll up to when it calculated the 0.539, and I'm going to hit enter. And it's going to copy paste it for me. And then I can hit enter one more time and get about 207. And then lastly, this was a rounded number. This is not. When possible, use exact values to find other values. So rather than multiply the 207 by the 0.539, since this is a rounded number, I'm going to multiply 384. But how many times do I have to multiply by r? Twice. So that's the 0.539 number squared, like that. So I'm going to do this. 384 times, I'm going to scroll up to the 0.539 thing. Then I'm going to hit the square button and hit enter. And I'm going to get that it's about 112. Ta-da. Working smarter, not harder. Trying to use the calculator as much as possible when I'm doing a calculator question. Cool? All right. Skirt! You're offered a starting salary of $37,500 for the first year, and you could tell when these things were made. Could you imagine a job that only makes $37,500? You have to live at home still. Anyway, you're offered a starting salary of $37,500 for the first year with an annual increase of 5% per year. This means your salary will be 1.05 times what it was the year before. Okay? Because it's your salary plus 5% more of your salary. What would you expect to earn in your 5th year? This is for the first year. So in this context, if it's the first year, is that A1 or A0? It's the first year, so it's the first year, so it's A1. So we know A1 is 37,500. We know R is 1.05. All we need is, yes? Because if it was A0, that would imply that after 1 year of, for the first year of work, I don't want to say this. It's almost like if you got paid at the end of the year in one lump salary instead of them splitting it up over the year, then I could make an argument for that being A0. There is no A0. That doesn't exist for this, and that's my point. A0 really doesn't exist ever. A0 would imply the money you made before your first 5% raise. But it doesn't make any sense in this scenario. Because it says this is your first year. Now, if it had just said, hey, we're going to hire you on at this amount, how much will you be making after 5 raises? If you wanted to think about it like that, maybe. Because you're thinking at the end of the year, I get this raise, right? But that would be your second year salary, wouldn't it? After 1 year's work. Yeah. Okay, is that better if I say it that way? Yeah. Okay, cool. So let us, and I'm going to write in green since it's money, money, money. I wonder how much money I'm making in that 5th year. I got the 37,500, 1.05 raised to the 5 minus 1. Because that's A1, not A0. 37,500 times 1.05 raised to the 4th is still not enough money to live. You've been lied to? If you put it all on green and green hits, you still wouldn't be rich. If you put all that on green and green hits, you would have that much money. You're not rich. That's not rich. How is that rich? You think $1.5 million is rich?
It's a good start.
I mean, it's a good start, but it's not rich. Oh, by the way, By the way, there's something in this country called winnings tax. So you would only get to keep about 60% of that.
Fine, I'll take your word.
So now you have less than $1 million because Uncle Sam is taking 40% of your money. Oh, it should be basically $1 million. Yeah, I mean, oh yeah,
If you like
yeah.
rebet it on black.
Okay, if you rebet it on black, you see black. Oh no, I multiplied by 35. If you're playing on an American wheel, I'm sorry. If it's an American wheel, you would have half of that because there's 2 green spaces. So if you bet on one of them and you got lucky, then it's times 35. But if you bet on both of them at the same time, it actually would have been this money times 17. And this would be the last gambling question because we have to finish the lesson. You'd only have that much money. By the way, Uncle Sam gets 40% of your money. So essentially, I'd like for you to see what just happened. It's the same amount of money.
If somebody came up to you and this much money, it's like 5 years for most people's salary.
Exactly. Yeah, well, that's why we don't gamble, folks. It's stupid. There's a reason why the lottery is called the poor tax. Anyway, we're flipping the page. Here's something we can all relate to in Florida, a Christmas tree farm. So a Christmas tree farm has 10,000 trees on its property in the year 2022. And each year after that, 10% of the trees are harvested. What? Write a general formula that gives the current number of trees on the farm in years where n equals 0 is 2022. So then what is a sub 0? It's green, right? Because trees. A sub 0 is 10,000 this time because it says n equals 0 is 2022. See, it's contextual. You just have to pay attention to the question. If we're harvesting 10% of the trees, how many trees are left? No. Okay, pretend you have no idea what we started with. If you harvest 10%, what's left? 90%. Great. That tells me R is 0.9. See, because percentages are multiplicative. So a general formula is T sub n equals, since we're starting at a sub 0, it's times R to the n. Not n minus 1 because we started at a sub 0. Then it says to use the formula that you have here to figure out how many trees, use the formula to find the number of trees that are left after this many years. But what is happening to the rate of change of the Christmas trees over time? Okay, well, let's just go ahead and figure out what's up. First of all, could I do 10,000 times 0.9, then times 0.9, then times 0.9? I could. But darn it, I want to use my technology. So I'm going to go to y equals. And what I'm going to do in here is I'm going to type this. 10, 1, 2, 3 times 0.9 raised to the x. Because I don't want to have to type times 1. I don't want to have to type a 1, a 2, a 3, and a 4 in. Instead, I want to use the table. Second table. Oh, look! Look at that. That's how many trees are on my farm right now. You were told about it before, you just weren't paying attention. You could do that too. So let's see. T sub 1, there's 9,000 trees left on the farm. T sub 2, there's 8,100 trees on the farm. T sub 3, 7,290 trees on the farm. And T sub 4 is 6,561. Great. So it says, what is happening to the rate of change? Well, the rate of change is how you got from one term to the next, right? So to get from here to here, that's minus 900. To get from here to here, it's minus 810. And to get from here to here, it's minus 729. Coincidentally, that starts with 729, which is actually kind of cool. Now, these are my rates of change. Yeah, do you know why it worked every single time? Because if you multiply by 10% of something, just takes a decimal off the end of it. So 10% of 9,000 is 900. 10% of 8,100 is 810. 10% of 7,290 is 729.
Oh.
Yeah. 10% of 5,000 is 500. Just things like that. Anyway, what is happening to the rate of change? This is increasing. Negative 900 is smaller than negative 810, is smaller than negative 729. My rate of change is increasing.
When will it become positive?
It would be impossible for it to become positive because that would mean that we grew trees. No, we're only harvesting every year. We're not replacing these trees. We're very short-sighted tree farmers, okay?
Does this have an asymptote?
Hey, I got a question for you. The number of trees on the farm, is it increasing or decreasing? Wait, okay, so the number of trees is decreasing, but the rate of change is increasing. So this is a decreasing graph that is concave up. That means it looks like this. It's a decreasing graph that is concave up. Isn't that neat? Concave up? Like that? Like horns?
Oh, I see. I was on the left part.
Because the rate of change is increasing.
It never goes back up.
It'll never go back up though. It has a horizontal asymptote at 0 when we run out of trees. Okay, next. A ball is dropped from a height of 30 feet. Each time it hits the ground, the ball bounces up to 0.8 of the previous height. Okay, in order to make this question make sense, we have to change the scenario a little bit because there's a 30 here after one bounce. So a ball is dropped from a height. It bounces to 30 feet the first bounce. Okay, now the table makes sense. And then each time it bounces up to 0.8 of the previous height. Okay? So the story didn't match what was already in the table. So we amended the story so the table makes sense. So we don't know what the initial height was, but we do know that after it hit the ground, it bounced up to 30 feet. And every time after that, it's going to bounce to 80% of that. What does that make R? 0.8. Right here, I'm going to skip to part B before I fill out the table. How high will the ball bounce after it strikes the ground for the nth time? Since this one starts with A1. There. And why did I do part B first? Because I'm going to use the table to get all of these numbers. That's why. Uh, 30 times 0.8. What? This is not going to be on a no calculator portion. Stop it. X minus 1. Second table. And now I have all of my numbers. Oh, clearly the table was 37.5 feet. Whatever. Here we have our numbers. 24, 19.2, 15.36, 12.288. Round to 3 decimals, that's going to be 9.83. Round to 3 decimals, 7.864. Suck it in, math, get skinny. And 6.292. So much faster than actually multiplying all that crap out. Part C. How many times will the ball need to strike the ground before it bounces less than 1 foot? You have two options. You could graph it and graph y equals 1 and then do second trace intersect. Or you could go to the table and just look for the number of bounces it took before the bounce height was less than 1. Looks like it took the 17 bounces before the bounce height was less than 1. It's even faster to second trace intersect as long as it's not going to take too long. Also, as long as the answer is allowed to be a whole number. Last question. Just enough time to at least discuss it. It says, what is the total distance the ball travels in the first 10 minutes? And be sure to consider the behavior of a bouncing ball. So, Does that mean I do 30 plus 24 plus 19.2 plus 15.36 plus? No, why not?
Because you do the pair thing.
Because balls bounce up and down. Because this is the path of the ball. So the total distance would be 2 times 30 plus 2 times 24 plus 2 times 19.2 plus ... all the way out to whatever the height was on the 10th bounce. So that was all the way down to that. But you would have to double each one of them. So you could find this number and then just times 2. That would work also, because they have an up and a down. No, it'll never say 0 because 0 is the horizontal asymptote. But in all actuality, does it ever become 0? Well, of course it does, because energy is lost to friction and sound and things like that. All right, nerds, I think that's it.